Welcome back to our enteral nutrition lesson. We're going to pick off right where we left off, and that's with bolus feeds. We'll still be talking about continuous feeds because understanding the difference is essential to solving these math problems confidently. So, what is the difference? In all enteral nutrition problems, patients are fed through some kind of tube because they can't eat food by mouth, but they still have a functioning GI tract. In continuous feed, the patient is always being fed. These type of tube feed problems deliver formula slowly and steadily over 24 hours using a pump. This method is really common in patients that are critically ill, patients who are sedated, or those who have poor GI tolerance. And so since the patient is being fed 24 hours continuously, we can figure out how many milliliters per hour, like we did in that last practice problem together. What are the patient's estimated energy requirements? What is the formulation of the tube feed? How many calories are provided in each milliliter of tube feed? In the last problem that we did together, the tube feed had 1.5 kilocalories per milliliter. It's an equivalent statement that lets us convert from calorie needs to volume of formula. Since there are 24 hours in one day, we can convert the total volume of tube feed per day into the milliliters provided every hour. That's continuous feeding, constant feeding over the 24 hours in a day. There is a third type of enteral nutrition, which is called cyclical feeding, where the patient is receiving continuous feeds, but maybe for only 20 hours in a day. And they work exactly the same way, but instead of using this equivalent statement right here, one day is 24 hours, these patients are maybe fed 20 hours a day or 18 hours a day. Maybe they're just fed at night for 8 hours a day, but the math works out the exact same way. Bolus feeds, on the other hand, are delivered in larger amounts at set times throughout the day. These are often used for patients at home, patients in rehab, or those who are transitioning off a tube feed because they're more natural, they're closer to how we eat, and they give patients a break from the pump. With bolus feeds, instead of a constant milliliter per hour rate, what you need to do is divide the day's volumes into multiple feedings. There is some notation to know here, like for instance, every 4 hours, we typically write that as Q4H, where Q is every, 4 is 4, and H is hours, Q4 hours. If you were giving a bolus every 6 hours, every again is Q 6 hours, Q 6 hours is every 6 hours, but every 6 hours is 4 times a day. So we could also write this QID, which means 4 times a day. Another common one that you often see is QD. It just means every day. And you might see notations like this on the RD exam for the enteral nutrition problems. The more practice you do with these, the more you will be able to recognize these acronyms. But here's the great part. No matter what type of feeding, continuous or bolus, the math stays exactly the same. We're going to use dimensional analysis, but this time in bolus feeds, we're figuring out how many cartons or milliliters are needed every day. And so then we'll be able to figure out how many grams of protein and carbohydrates and how much free water the feed is providing. So let's walk through an example together. Here we have a patient who needs 2,230 calories every day. They are transitioning to bolus feeds. So they'll be getting a carton, and that carton has 250 milliliters in each carton. In that 250 milliliters, there's 350 calories, 16 grams of protein. We've got 40 grams of carbohydrates here. It's 72% free water. So we're trying to figure out how many of this bolus feed, how many cartons does this patient need to get every single day to meet their needs? But the calculations are the exact same that you've been practicing. So the first thing that we always need to do is to determine our goal volume by looking at the estimated calorie needs, convert from calorie needs to either the target volume, or for bolus, how many cartons is the patient going to be receiving. So their estimated needs, 2,230 calories per day. And so what we need to do is to convert from calories into cartons. And we know how many calories are in a carton. Each one carton provides 350 calories. Since these two things are equal to each other, we can say in every 1 carton that a patient takes in, they are receiving 350 calories. Or if they have taken in 350 calories, then that must have means that they've consumed 1 whole carton. These two values are equal to each other because they're equal to that equivalent statement. But what we're trying to do is to convert from calories. This patient has 2,230 calories of estimated needs, so calories goes in the bottom to cancel out. We want this equivalent statement right here because its units match. Calories cancels out, and we find out that this patient needs to take in 6.37 cartons a day. Now, I have been taught to round, and so I would round this down to 6 cartons a day. I mean, try to tell someone to drink 0.37 of a carton every day. And 6 cartons a day comes out to 1 carton every 4 hours. Drink a carton every 4 hours times 6 a day, and it'll be 24 hours. And if I was a patient needing to maintain this on my own, thinking, okay, I need to administer or take in 1 carton every 4 hours is a little bit easier than having 1.05 cartons every 4 hours. And since we're rounding down here, we might be a little bit low on our needs, but let's just take it all the way through. So if this patient is receiving 6 cartons a day, and we know that every carton has 250 milliliters, we can determine the goal volume, the amount of nutrition that would be administered if this patient takes in 6 cartons a day. Because our equivalent statement is every carton has 250 milliliters. So if they're taking in 6 cartons, then that means this patient is receiving 1,500 milliliters of this nutrition every single day. And this right here, that's my goal volume. 1.5 liters or 1,500 milliliters is my goal volume if that patient takes in 6 cartons a day. So now that we know the patient is going to take in 6 cartons a day and receive 1,500 milliliters of this bolus tube feed, we need to figure out what that provides nutritionally. And as before, we'll look at calories, protein, carbohydrates, and free water. And the equivalent statements are given to us in these problems right here. The feed has 250 milliliters per carton, and each carton provides 350 calories. So here's my equivalent statement from cartons to calories. I'm going to write that under calories. 1 carton gives us 350 calories. So we can take our goal volume of 6 cartons a day and figure out how many calories that is. For protein, we know that each carton, again, provides 16 grams of protein. And we know that each carton provides 40 grams of carbohydrates. So those are my equivalent statements to determine the nutrition that's provided. And for the free water, it's 72% free water, and we're providing 1,500 milliliters a day. You try it. What's the total nutrition provided? To find the nutrition, we're going to take the cartons that we administer every single day and use our equivalent statements to convert from cartons to calories. There's 350 calories in 1 carton, and if this patient is getting 6 cartons, then they're taking in 2,100 calories per day. A little bit light on the estimated needs, but we don't need to hit 100% of estimated needs, usually around 90, more than 90%. So if this patient is getting 2,100 calories per need and their estimated needs are 2,230, that's 94% of the calories being met. That's fine that we rounded down. And if you chose to not round down, that would be fine as well. You're probably right on the money here with exactly how many calories need to be provided. For protein, we'll take our 6 cartons and convert from cartons to grams of protein. Every single one of these cartons has 16 grams of protein. So if we take in 6 cartons, then we're taking in 96 grams of protein. Same thing for carbohydrates. We'll take our 6 cartons and convert it to grams of carbohydrates. That comes out to be 240 grams of carbohydrates. And for free water, since it's 72% free water, we're administering 1,500 milliliters. That's 1,080 milliliters of free water. Again, this is likely not meeting water needs. If this patient is taking in 2,100 calories a day, then they probably need 2,100 milliliters. But for bolus feeds, we always have some kind of free water flush. Even for continuous feeds, free water flushes are really common. And we'll talk more about how to meet the additional water needs when we get to Module 4. So we can get to the point now where we state our nutrition recommendation. We don't know the name of the tube feed here, but we know it's a bolus feed with 250 milliliter cartons. We're giving 6 cartons a day. That's 1 carton every 4 hours, Q4H. The volume per bolus is 250 milliliters because we're giving 1 carton at a time. In total, that's providing a goal volume of 1,500 milliliters every single day. It's giving 2,100 calories every single day and 96 grams of protein. We know that it provides 1,080 milliliters of free water. So this recommendation written this way is the clinical notation to say administer 1 carton, 250 milliliters, every 4 hours for a total of 6 cartons per day to give 2,100 kilocalories, 96 grams of protein, and 1,080 milliliters of free water. Again, the RD exam probably isn't going to ask you to state a recommendation, but by giving the volume, the frequency, and what it provides, we apply these numbers and calculations to patients in need. And that's what dietitians do every day. But moreover, if you can state the recommendation and go through these calculations logically, you'll definitely get the problems right on the RD exam. Take your time. We solve every single one the same way, looking at the goal volume, thinking about the nutrition provided, and then checking those recommendations. And if this is feeling overwhelming, that's okay. There is time. We've been building towards this. But that does not mean you need to be an expert right now. So keep working at it. Thank you for your attention, and I will see you in the next one.